So yeah, my talk is Web3 for data scientists. If you're interested, I can just send the slides over after the talk. I'm very happy to make them available. And the company I'm the founder of a company called Moonstream. At Moonstream, we've been always big believers in open source software and in decentralized software. We specialize in basically crawling data from blockchains and analyzing that data from blockchains. So we're an open source blockchain analytics platform. And everything that we do it in the open. So all of the code that we write is open source code. We've written a lot of infrastructure code and a lot of crawling code that makes it easy to take data from blockchains and build data sets out of it. We release public data sets periodically. The most recent one we released that got a lot of attention was we released an analysis of the Ethereum NFT market, and that data set is available on Kaggle if anybody wants to interact with it and play with it. We're always available on Discord to answer questions. So here's a link to our Discord. We also have a decentralized autonomous organization, or DAO, right now it's our core team that makes up the DAO, but we're opening up access to this to basically the whole world. So anyone who wants to contribute and participate in our projects, they can do so through the DAO, and then compensation and everything is also handled through the DAO. So that's us. That's Moonstream, and we have a lot of experience. In today's world, it used to be several years ago, there was several years ago, there was Bitcoin, and then there was Bitcoin, and there was Ethereum, and maybe Stellar, and a few other major blockchains. And now there's a lot more blockchains. Our expertise is really on the Ethereum-based blockchains. So right now, Moonstream supports Ethereum and Polygon. We're building a bridge from Ethereum to Stellar, so we understand about those other blockchains as well. We understand about Solana as well, but really we focus on Ethereum. And my talk today is going to be focused, when I say blockchain, I really mean an Ethereum-based blockchain. So either Ethereum or a blockchain which is using the same technology as Ethereum in order to run the blockchain. So the same data structures, the same code. They might be running a completely different network, but the underlying technology is the same as Ethereum. So that's what we're going to focus on. And there's a lot of blockchains like that. There are big ones that there's of course there's Ethereum, but then there's Polygon, which is a pretty good up and comer. There's the Binance Smart Chain, which is how the Binance exchange runs all of their decentralized stuff. They have low transaction fees. There are new blockchains like Forte, which are meant specifically for to give an easy financial on-ramp to projects, things like that. We focus on these kinds of blockchains. Okay, so we're going to teach you how to build data sets from these blockchains. And the important thing about these blockchains is not all blockchains support smart contracts. So it's really important to make this distinction between blockchains. Like Bitcoin, for example, the use case for Bitcoin is mostly payments. You can write some data into Bitcoin. You can write some low-level programs as well into Bitcoin. But for the most part, people are using Bitcoin to send value from one party to another. Ethereum was really revolutionary because the whole idea of Ethereum was not just this system, a decentralized system for transferring value from one party to another. Ethereum was founded as basically a world computer, right? So that was the catchphrase that was the Ethereum catchphrase for a long time. I don't think anyone thinks about that anymore these days. These days, Ethereum is a way to do decentralized finance and this and that and the other thing. But the reason that Ethereum can be all of those things at the same time is because Ethereum was built as a world computer. So the Ethereum blockchain is very interesting in that Ethereum transactions, you can actually deploy programs to the Ethereum blockchain which execute on the blockchain. And you can make those programs execute against some input by submitting transactions to the blockchain. And the results of that execution can determine some downstream action. If some condition is met, I want to pay this person this amount of money, or I don't. Or if some condition is met, I would like to transfer this digital asset to this person, otherwise I won't, right? You can implement that kind of logic on the Ethereum blockchain. And over the years, projects have been building up more and more layers of abstraction on that basic functionality to build really quite complex software, like decentralized exchanges, games. People are building all kinds of really interesting stuff on Ethereum using those low-level computational primitives that Ethereum exposes. And so that's what we're going to talk about over here. From a data scientist perspective, are there any questions, by the way? Let me keep chat open on a different window. There we go. So let's see. It would be super interesting to join our DAO. If you want to join our DAO, just come and start talking to us on Discord, and then we'll give you sort of a token that gives you access to our DAO. Kiran asks, is there any technology or platform where we can develop blockchain applications without extensive coding or with low coding? I think we're at a stage right now in blockchain development that you have to understand about the underlying technology when you're doing development, especially if you're actually deploying contracts or deploying programs to a main network, like the Ethereum mainnet or Polygon mainnet or something like that, for the simple reason that if your application is successful, you're liable for the security of your application. If people are putting like their life savings or like putting like substantial amounts of money through your application, like for example, we just did a large NFT sale. We participated in a large NFT sale that saw like that's seen tens of millions of dollars in transaction volume. That's tens of millions of dollars flowing through our smart contracts that I don't know if we're legally liable for it. That's still sort of a gray area, like what happens, who comes after you, but we're certainly morally liable for it. The crypto unicorn sale on Polygon. So we're morally liable for it. Like people are actually like dumping serious amounts of money into these digital assets, and the people who actually program those assets, they have some sort of responsibility to people who are using those programs, right? And we still don't understand enough about security yet where I would feel comfortable, for example, using some sort of a no-code or low-code tool to do a deployment. I don't think it would be able to capture like any sort of functionality that would be particularly interesting. So I think basically we're just in too early stages of just blockchain technology, this type of like functionality on the blockchain for those tools to exist and for those tools to be like trustworthy or reliable. Because there are a lot of problems that go into it, right? From the matter of like who controls the keys that get to take certain actions against like in those low-code tools and stuff like that. So it's a little bit too early for that. I think at this point, if you want to build applications on the blockchain, you really would be doing yourself an injustice by not digging in and really understanding how things work at a low level. But if you want to build applications that use data from the blockchain, that's like a little bit of a different story, because over there the stakes are much lower. Just in terms of like how much is at risk in like a single action or at a single point in time, the stakes are much lower. And it's actually a good point at which to enter the system, and that's what I'm going to be talking about today. And so basically what I'm going to cover is I just want to provide you guys, if you want to do a deep dive, there are like really great places to do a deep dive. You can start with the Ethereum white papers, or Ethereum has really great developer documentation that explains a lot of these concepts. There are YouTube videos, there are podcasts. I mean, there's a wealth of content that like will explain to you in very deep terms, how the blockchain is structured, how nodes write to the blockchain, how transactions enter the transaction pool, etc. And it's something that would be very difficult to cover in like a 50-minute talk, right? So instead, what I want to give you is I want to give you just enough knowledge that you feel comfortable, you understand like what the data structures are and what the interfaces are at your disposal if you want to build data sets and do analysis of data from the blockchain. And I want to provide you links with tools that you can use to then like go and do, if you're interested, like you dig deeper and do more work, right? Actually start building things, actually start writing code, and actually start collecting data. So I'm going to give you those pointers, and basically that's what the structure of this is going to be, right? If anyone's not familiar with the blockchain, I assume there are people here who have varying levels of experience with blockchains. So for people who don't have much experience, I'll just explain like the very basics of like how data is structured on the blockchain. I'll explain a little bit about smart contracts, what the important concepts are for you to know about smart contracts. And then I'll just talk about tooling, and I'll talk about data sets that you can already use and how you can build your own data sets from the blockchain. And Tina, what's the main goal for Moonstream? To crawl and explore Ethereum data? What does it mean Q&A, Murat? I don't know. Is there a different channel where people are asking,
No, there is a Q&A session there.
Oh, I don't mind. I don't mind if they ask now. I actually like this. I'll answer. I'll happily answer now. Actually,
the issue is sometimes in the chat people make comments and you confuse, or comments to us. That's why Q&A is more organized. It's either way, it's whatever works for you.
Okay. So is there like I don't know how I would see the Q&A question. So let's do this. It's okay. I'm happy to answer Tina's question. So Tina, the goal for Moonstream is, the technology that we've built it's a great way to connect on-chain programs to off-chain programs. So it's not that we just want to crawl and explore Ethereum data. We're a company, we need to make money to survive. But the way that we do that is that we have a product which makes it easy to connect on-chain programs like smart contracts to off-chain programs. If somebody's running, for example, we're gaining a lot of traction in the NFT gaming industry, because usually you have like a game server in it that needs to be aware of what's happening on a blockchain in order to function appropriately or effectively. And building that sort of blockchain aware game server is a very difficult task. But if somebody integrates with Moonstream's API, they automatically get access to an event stream of everything that's going on the blockchain that's like reliable and always up. And so that's sort of the way that we've been growing for the last several months. And we're just making that easier and easier and easier, connecting what's happening on chain to like something that process that you already have off chain. But doing that requires us to crawl the blockchain, and it requires us to crawl the blockchain reliably, and it requires us to sort of really understand very well, in the context of the semantics of whatever project is sort of doing the crawling, they should be able to like take these blockchain events and like put them into their regular workflows. So the format in which we provide them data really matters a lot, and so that's why we spend a lot of our time thinking about blockchain data. Okay. All right. So let's talk about the data structures on the blockchain. Okay, so this is basically just the stuff that you need to know. There's a lot more that goes into this, but this is a good place to start. And already with this information, you'll be able to like go start crawling data and actually start making sense of it, start analyzing. Okay, so the most basic thing you need to understand about, let's say, the Ethereum blockchain is that users submit transactions in order to change the state of the blockchain. The transactions can transfer value from them to someone else. They can deploy a smart contract onto the Ethereum blockchain or Ethereum-based blockchain, or they can execute some function of that smart contract. Okay, so that's like basically what transactions can do. And when you submit a transaction, it doesn't immediately take effect. What happens is you submit your transaction to a mining node or to a node. The transaction gets picked up by mining nodes. Mining nodes mine batches of transactions onto the blockchain. So transactions sort of get written to the blockchain in batches. And those are called transaction blocks. Okay, so transactions are written to the blockchain in blocks of transactions. On Ethereum, you have roughly 200 transactions per block on average that get written to the blockchain at the same time. And the rate at which blocks are written to the blockchain on Ethereum is roughly one block every 15 seconds. Okay, so Ethereum supports Ethereum supports about 800 transactions per minute, right? That's sort of like that's the average traffic that you would see on the Ethereum blockchain. The interesting thing about transactions, and this is especially important on Ethereum, is that transactions happen atomically on the blockchain, and they're executed in a fixed order. Even within a block, the transactions have an order, and they're all executed in order. And that's really important because one transaction might like depend on the state that another transaction in the same block changed, and so it's really important to have a canonical order in which transactions are executed, and that's decided by the miner. So, but the important thing here is that the transactions are atomic. Okay, and because they refer to a common state, right? Because every program has a state in common with every other program, and so it's important that they be atomic. So that's the important thing here is just that you have transactions and then you have blocks of transactions, and that's how data is written to the blockchain. That's the most important thing that you should take away from this slide, is that you have transactions and then blocks of transactions. So when you're crawling the blockchain, you start by pulling blocks out, and then you analyze each of the transactions that happened inside the block that you pulled out. Okay. All right. Now, smart contracts, they're programs which execute on the blockchain. So a program is not so useful unless it has like some sort of a notion of memory, especially like a program that's running over a long period of time. So there's something called Ethereum state, which programs can store data in, and then they can access data from that state when they execute on the blockchain. And an Ethereum program, a smart contract, exposes methods, right, which can modify the Ethereum state. And a program, the other interesting thing from a data scientist point of view is that programs also can emit events. Events that programs emit are actually not available to other programs on the blockchain. They're not stored in Ethereum state. There's a separate storage that every node, they are permanently stored, but not in Ethereum state. They're stored somewhere else, and they designate like events. So if a program like did some sort of a computation and achieved some sort of a result, it's very common that it'll emit an event that's like describes what result it achieved, so that people can look up, crawl through the blockchain and look for similar events, at some point in the future. These events are actually really important if you're doing data analysis on the blockchain. So a good example of this is, there are these standard ways of creating tokens on blockchain. So ERC20 is a token standard. Actually, it was like very popular in 2017, 2018, and now it's just become a complete standard, right? You can create your own currency basically, and ERC20 represents like basically some sort of a currency, a fungible token, and ERC721 represents non-fungible tokens, NFTs. If you guys have, and the NFT market is like insanely hot right now. ERC721 is the standard that defines what interface an NFT needs to have on Ethereum in order to play well with the rest of the ecosystem. And all of those tokens, for example, both ERC20 tokens and ERC721 smart contracts, they emit transfer events when somebody transfers a token on that contract from, to someone else. So if you wanted to analyze like how ownership of tokens had changed over time, you could do it purely, you wouldn't have to crawl transactions or blocks or anything. You could do it purely by crawling events, transfer events for that token standard from the blockchain. Okay. Now, every smart contract that gets deployed, because it's just a bunch of bytes that you're putting on the blockchain, right? There has to be some way for that bunch of bytes to turn it, like be interpreted as a program by the blockchain. And that sort of method of interpretation is the application binary interface, or ABI. So every smart contract has an ABI, which basically defines how the entry points into the program, right? Like what are the different functions on the program that you can execute? What are the different events that the program emits, as part of its execution, okay? I can show you an example of an ABI. On the Ethereum blockchain, an ABI is typically just, there's Q&A here. Okay, this Q&A is not from me. It's about why Magnimind talk started at 11:50. Yeah, an ABI on the Ethereum blockchain is just a JSON file. It's a list, it's a JSON list of functions and events, and then the arguments that they take. So for example, you can see that on an ERC20 token, there's an approval event, and it's emitted with an owner, a spender, and a value. So basically what this means is that if I have, like, let's say that I have 100 ERC20 tokens, and I want to approve Murat to spend them on my behalf, I can call an approve function on the ERC20 saying that, okay, I want to approve Murat to spend, I'm sorry, let me zoom in. Okay, I want to approve Murat to spend like 100 of my, or let's say 50 of my tokens at any time of his choosing. I would make an approval call. And when I make that approval call, an approval event would get fired with my address as owner, with Murat's address as spender, and with 50 or, over here as the value. So they would say that way you could crawl, if you crawled the blockchain for approval events on that contract, you would see that, at some point in time, Neeraj said that it was okay for Murat to spend 50 tokens on his behalf, right? You could reconstruct that event by crawling that contract, okay? But the ABI, basically what you need to know, it's a JSON file, it's a JSON list. It basically lists the functions and events that a smart contract fires. That's what you need to know there, okay? Now you you understand about transactions, you understand about transaction blocks, you understand about smart contract, ABIs. What do you do with this understanding, right? This understanding is useless unless you can actually interact with the blockchain and put this knowledge to use. So in order to do that, you need to have access to a blockchain node. in the old days, that meant you had to run a node yourself, basically, right? You would have to like find some hardware, spin up a computer. You don't have to run a mining node. You don't have to, you don't need some fancy GPU or anything, but you at least need a node that's participating in like all of the communication that's taking place to build like a distributed common distributed ledger. Okay. These days, like new blockchains just offer public APIs that give you access to their nodes. So for example, on Polygon, there's polygonrpc.com. On Solana, they have api.mainnet beta. I don't know when they'll get out of beta, but mainnetbeta.solana.com. And you can do the same thing. You can make the same calls against these APIs that you would make against like a node that you were running, and it'll return data from basically these nodes are run by the foundation. So there's a Polygon Foundation. I think they run polygonrpc.com. Solana, the company, runs this endpoint. How to ensure that smart contracts designed on Ethereum can be used with layer 2 blockchains. So this is from Jewel in the question. So it depends on the layer 2. If you've written a smart contract, let's say in Solidity, then it can like either you need to, okay, let's say you've written a smart contract in Solidity. If you want the development experience to be the same on the L2, then that L2 needs to support Solidity. If you want the compiled smart contract to be executable on an L2, then the layer 2 blockchain needs to like have Ethereum virtual machine support, right? Because your Solidity smart contract will compile down into like Ethereum virtual machine bytecode, and you need to have an L2 that supports the EVM. But it's also possible to have L2s that don't support the EVM, that aren't EVM compatible, that only write proofs of transactions back to the Ethereum blockchain. That's a different story then. So basically the answer is it doesn't depend on your smart contracts, it depends on the L2 that you want to get on. That's the answer to your question, right? But yeah, so on Ethereum, there's no public endpoint that I know of, at least, where you can just hit the hit like a node on the Ethereum mainnet. But there's a service called Infura. Everything seems to be centralizing around Infura for interacting with the Ethereum blockchain. But if you go to infura.io, you can create an account for free, and you can, you'll have access to a node that that's connected to the Ethereum, that's on the Ethereum mainnet. And there's a limit to how much you can use it. You can't abuse it, but it's good enough for most crawling purposes. I've never had an issue. We run our own nodes, but sometimes every now and then, like I just crawl from Infura, and I've never had an issue with it. Okay, so this is how you get access to nodes. Okay, so these things these things describe how you get access to nodes. There are also tools that you need to know about. If you have access to a node, that's not good enough. You could make like raw, like curl calls, like HTTP calls to the node, but that's not very convenient if you're writing a program. There are libraries that you can use. So I think JavaScript is sort of the language of Web3. Govind, I think that's a question that's better to answer later on, use cases for using the data from the blockchain. But the obvious one is make a lot of money, right? Like if you can find arbitrage opportunities on the blockchain by crawling that data, go and become rich. I think that's the best, most exciting use case for most people for using data from the blockchain. But there's many others as well. But yeah, so the low-level tools are Web3.js and Web3.py. I use, my team uses a lot of Python, so that's why Web3.py made it on the list. But as I said, JavaScript is sort of the language of Web3, and Web3.js is sort of the low-level tool of choice. It's the official JavaScript library that allows you to talk to Ethereum. Other blockchains like Solana, even though it's not Ethereum-based, they have like Solana Web3.js. Everybody's sort of centralizing on that pattern of, converging on this pattern of releasing a Web3.js library that helps developers talk to their blockchain. So those are sort of the low-level tools. They allow you to, you don't have to make like curl calls or make raw HTTP requests. They give you a nice sort of wrapper in the programming language of your choice that allows you to talk to your chosen blockchain. And then there are high-level tools. Like for example, Moonworm is a tool that my team has developed, which it generates code. So basically, let's say that you have some sort of a smart contract that you want to analyze, and you have its API. You can get its API from a blockchain explorer. You can use Moonworm to just generate a Python interface to that smart contract. And Moonworm will also give you an automatic crawler. So basically, if you run Moonworm against a contract, it'll just it'll spit out, you just say like, I want to run Moonworm against this contract. It has this ABI from this block to this block, basically from this time to this time. And it'll just start spitting out to you like all of the events and all of the function calls that were made against that contract between those periods of time. Okay, so that's these are the tools that you can use to interact with the blockchain, and the links are available here. So when you have the slides, you can click through and explore them some more. And these are so basically like, this is the way that we build data sets in Moonstream, and this is the way that I would recommend to anyone to build data sets, blockchain related data sets. If you want to start playing with blockchain data, you can already start, there are public data sets available. As I said, we publish data sets on Kaggle periodically, like we try to publish a new data set once every 3 months. There's also a public Ethereum data set on Google BigQuery. It's actually a pretty good data set. They keep it up to date. It's very high quality, but it will cost money. So if you run operations on Google Cloud BigQuery against the Ethereum public data set, it will use up cloud credits if you have them. If you don't have cloud credits, you're going to have to pay for that execution. So just be careful, because it's a pretty large data set, and if you run like an operation over the entire data set, it could cost you like hundreds or thousands of dollars. You just have to be careful. You can also build your own data set. So basically what I want to tell you is that you have the power to build your own data set. So if you have a question, about, I'm curious about this activity on the blockchain, or I want to understand how large the NFT market is on the blockchain, or I want to understand how many billions of dollars are being traded on decentralized exchanges, you don't have to rely on other people to get those to like give you those answers. You are data scientists, and now you have the tools that you need in order to actually like build the data sets that you need to answer those questions. So that's sort of like the moral of my talk anyway. So that's what I would encourage you to do. And if you want an example, with the Ethereum NFT market, because we're so active over there, we've published a report, which is available again on our GitHub, that does an analysis of the Ethereum NFT market. The link is on the top, and our full data set is available on Kaggle again. Okay. Right. And yeah, if you want to dig deeper into any of, Murat, can I send you the slides for this talk and you can share them with the community? Would that work?
Yeah, if you share with that email that had you talked about invitation, our friends will share that.
Okay, great. I'll send it to you then. Okay. And then if you want to dig deeper, into our code, like I said, everything that we build is open source and is freely licensed under either Apache 2 or MIT. You can go here. If you want to check out our data, it's available on Kaggle. If you want to try out Moonstream as a product or use the API, just go to moonstream.to. That's our website. Join our community. On all of these places, my username is Zomglings, and I'm very happy to like have a conversation with any of you. Just ping me. I'm happy to talk. Okay. So that's my talk, and now I'll answer as many questions as you guys have for the next 25 minutes.
So we got a lot of questions in Q&A. If you look
Q&A.
at the
Okay, I see Q&A now.
Yeah,
I see it now. I am starting my master's course on data analytics, Lakshmi. How much this subject of today going to help in my profile? I mean, blockchain is extremely fashionable right now, so I expect it will help you a lot in your profile. Okay. Then Hubert asks, is it possible to get data from the mempool with Moonworm? Yes, it is possible. Not with Moonworm, but with Moonstream. So we crawl mempool data from our nodes. We call transaction pool data from our Ethereum nodes and our Polygon nodes, and it's available through the Moonstream API. That's open source as well. So for example, if you're running your own node and you want to crawl transaction pool data, you can use Moonstream open source to do that. So that's very much possible. Yeah, with transaction pool data, it expires after an hour. So if you wanted to store it for a long period of time, we don't store it. The storage requirements for the transaction pool would be insane. It would cost like way too much money to store transaction pool data for a long time. So you just set up a subscription, and if you need to store it somewhere else, if you need to persist more than an hour, you can handle that yourself through our API. Okay. So Jerry, in your NFT analysis paper, Is it also explained how you crawl the data, like which smart contracts, etc.? Yeah, we explain how we crawl the data. We're actually in the process of doing an update to the data set and an update to the research, and we're going to go into a deeper explanation of how we crawl the data, because when we did the first one, Moonworm didn't exist, and now Moonworm exists, so that'll work. Okay. Louis, hi there. My company mints NFTs for volumetric video. We are also exploring eye tracking for our assets that all go on different blockchains. What are some of your thoughts on maximizing the tiny bandwidth in the near future? Would be amazing. Thank you for the great talk. So you mint NFTs for volumetric video. I don't actually understand what that means. What does it mean that you mint NFTs for volumetric video? Do you mint NFTs that represent the videos, or do you mean something else? And I guess you want, okay? So do you store like a hash or some sort of a signature from the video in the NFTs? Is that how it works? So yeah, if you're storing some sort of like a signature from it's going. I think it would be very hard to reproduce the video. To store enough state on the blockchain that allows the user to completely reproduce that video. That sounds like it would be quite difficult to do. I think my solution over here my recommendation would be to use some kind of a machine learning model. So basically you could extract some sort of feature or find some sort of a latent representation of the contents of the video that uniquely identified the video, and then but I guess it depends on what your need is. Do you need to like provide permanent access to the video? If that's the case, then like maybe you need to store the video on like decentralized storage like Arweave or IPFS, and then make it so that the signature, like some secret signature of the video unlocks the video. But I don't know exactly what the use case is over there. Actually, I would be happy to talk about it, but maybe it would be better to talk like offline, maybe on Discord or something. So if you want to talk about it further, like I would be happy to continue the conversation. But maybe it's like, yeah, not good for the Q&A session right now. It's quite interesting though. I mean, I've thought about these kinds of things a lot, so I would be happy to continue the conversation. Okay. I'm sorry I missed. What is Web3? How does it relate, if at all, to the web as we know it? So I think the Web3 used to refer to something different in the days of the semantic web. What people mean right now when they talk about Web3 is programs that run on a blockchain, basically decentralized applications that run on some sort of a public ledger, like a blockchain. That's and like, there's a whole ecosystem of these programs that are building off of each other and communicating with each other, like even now as we speak. That ecosystem of programs is Web3. And it certainly does relate to the web as we know it, because the web, like regular World Wide Web, it just permeates our lives, right? Everything that we do probably like involves the web, especially like those of us that are like on Zoom right now, right? There might be people in the world who just don't care anything about the web, or for whom it doesn't affect their lives, but for us, it certainly does. That means that it's really important for any Web3 program, any decentralized application, to have some sort of a connection to the existing World Wide Web infrastructure. The Web3 programs, they provide like sort of extra value, and this is debatable, right? Like blockchain skeptics will say that, oh, they're just like some sort of a Ponzi scheme or pump and dump kind of thing. I don't agree with that. I actually think that there's genuine value to what's happening in Web3, but that value it has to be accessible from like the regular web, right? People need a website to interact with the smart contracts. Otherwise, the number of people that can interact with a smart contract without a website is like, I don't know, probably in the thousands. But the hunger to interact with smart contracts is like, numbers in the billions. And the only way to sort of make that connection, to connect the supply to the demand, is by building regular web apps. And that's a very important thing as well. And that actually segues nicely into the next question, which is which languages should one know to pull data from the blockchain? You don't need to know any Solidity to pull data from the blockchain. JavaScript or Python, I would say Go as well. Like, the standard Ethereum implementation, the canonical one, is written in Go. There's a lot of great tools already in that code base that will help you pull data from the blockchain. But I think JavaScript is like your best bet. It has the most mature ecosystem in terms of tooling. Yeah. How is Moonstream going to make money? Well, we make money because our customers use our product to connect, to basically like understand in their server code, in their regular, like on their AWS servers and stuff like that, to understand what's going on the blockchain. And we just charge them a subscription fee for that, basically. So that's how we make money right now. And we're building extra features on top of our product, because the number of people that can use, an API in order to figure out what's going on a blockchain is like rather limited. There's not a lot of people who have expertise in making use of the blockchain data right now for that to be like a huge market. It will eventually be a huge market. So we've also started building like features that we need for our DAO anyway, which people who are using Moonstream need for their applications, and they have been growing like pretty well. So for example, we're releasing a decentralized authorization feature in Moonstream tomorrow. That it'll go live on the Polygon mainnet tomorrow, and then it'll go live on Ethereum mainnet like in March. And we already have customers lined up to use that. So we basically make money by making this connection between smart contracts and regular programs. Okay. What are some interesting data analysis problems that one can solve with this blockchain data mining? It really depends on your interests. Like there are people, as I said, finance is a big thing, right? There are hedge funds that that will become like, that will earn billions or maybe even like more hundreds of billions of dollars, I don't know, by finding arbitrage opportunities, by mining data from the blockchain to find arbitrage opportunities between decentralized exchanges or between like different financial protocols. You can probably also find exploits in many different smart contract protocols by analyzing the data, analyzing patterns of usage to make a lot of money. Although that would be, that'll be, don't tell me that you're doing that, or don't tell the police that you're doing that, I guess. But yeah, it just depends on your interest. Like people who are building games or who are trying to build like sort of common, shared worlds on the blockchain. For them, the data analysis would be around like, how do you improve engagement with sort of the worlds that you're creating on the blockchain? There's any number of use cases. It really depends on your imagination and your interest as well. Like, what are you interested in doing on the blockchain? Do I think that Ethereum price will go up in coming years or months? Yeah, I think Ethereum price will definitely go up, especially like once Ethereum 2.0 proves itself to be stable. I think it's just going to skyrocket. But I'm not giving you investment advice. Yeah. So in spite of all the hype, only one small nation has adapted the cryptocurrency. What is your take? I think it's not important for nations to adopt cryptocurrencies. The whole point of cryptocurrencies is that like national adoption doesn't matter. What matters is if like enough individuals adopt those currencies. And we've definitely seen over the last couple of years that people are ready and willing to do it, and companies are ready and willing to do it. If Facebook was willing to rebrand themselves as Meta and take that kind of a bet, and if Square was willing to rebrand themselves as Block and take that kind of a bet, like we've definitely like cryptocurrencies and blockchains have definitely reached sort of a different level of sort of acceptability or solidity, like solidness. Solidity is the programming language than they had in like 2017, right? So that's my take. What do I think about Bitcoin and Ethereum? It's a pretty general question. I don't know. I'm like trading all my Bitcoin for Ethereum. That's what I think right now. But again, that's not investment advice. Will the data science and machine learning jobs grow further because of Web3? I think so. I think that's actually true, just because we're just starting to scratch the surface in terms of like, what the potential is for Web3 in terms of, what kind of experiences we can build. And there's a real dearth of expertise of data analysis in that community. So basically, I don't think Web3 has had like a sufficient impact on data science yet. And I think that's going to happen in like the next year or two. Can I give a brief overview of what is currently done in data science applied to blockchains? I honestly think right now most of the applications are financial, and most people probably aren't talking about the stuff that really makes them money. So it's hard to give that sort of an overview. But there are a lot of papers being published about, that involve analyses of blockchain data. So I don't know, just pick like a journal that sounds interesting to you on the blockchain, and you'll probably find a good example of, if not where somebody is like properly applying data science to the blockchain, of something that's begging for data science to be applied to the blockchain. So that's maybe that's like, that doesn't really answer your question, but yeah, it's hard to answer that question. Okay, any ideas for how to store private data on the blockchain? I don't think, I don't think all data should be stored on the blockchain. I would not even try to store private data on the blockchain. Basically, let me put it that way. It's not a problem that it's not a pressing problem. It's never been a pressing problem for me. It's not a problem that like I want to solve. It's possible that it's a very important problem to solve, but it's just not something that like I would spend a lot of time thinking about. If I had to do it, I don't know, I would store the data in an encrypted form on like IPFS or on Arweave, and then I would put like a key that could decrypt the data in like a safe deposit box, and then I would sell someone on the blockchain access to the safe deposit box, something like that, right? All right. Do you believe that only very few layer 1 and layer 2 blockchains will be selected by the community over the rest? Which ones of the layer 2 blockchains do you think will prevail in the ecosystem? Thanks a lot for the talk. It's hard to say, like, it's hard to give numbers. I think there will be very few layer 1s, but I think there will be many layer 2s that exist, and I think they'll be specialized for different purposes. For the layer 2 blockchains, a lot of it depends on how well they capture like different segments of the community. Which ones of the layer 2 blockchains do you think will prevail? I personally think Polygon will do very well. I guess it didn't start off as a layer 2, but it's being treated that way now. I know like a lot of projects that are moving to Starkware, for example, for games, and people are definitely looking for, I think about games a lot, so that's why maybe my answer will be biased in terms of games, but people are looking for solutions where they can run on-chain games with like very reasonable transaction fees. So there are a bunch of blockchains that are now cropping up to support that kind of functionality. Yeah, my slides will be made available, Jim. I'll send them to Murat. Yeah, it's hard to say. I don't feel comfortable like making a prediction right now. The bets that we're making are public, right? Like we're building on Polygon, for example, and then we're probably going to build on Stellar. Like we're making a certain set of bets that we're doing publicly. Besides that, I don't really know. It's a crapshoot, I think. Does blockchain and Internet of Things connected? I think there are people who are trying to connect them, but I don't personally see that that's a very pressing or important thing to do right now. But all of these things just depend on your imagination and problems that people are having, right? I don't know what problems people are having in IoT, and I mean, to the extent that IoT can help the blockchain, I don't know. It would be really awesome if there were a blockchain that could run on my phone. But there's like Mina, right? Mina protocol. I haven't like done much research into it yet, but I would love for there to be a blockchain where I could run a node on my phone and participate on my phone. And I think it'll happen. It'll happen probably the next 5 years or something, that there will be something like that. 5-year predictions are kind of bullshit though. Who knows, right? Okay. Gas fee is very high on Ethereum compared to competitors, right? Yeah, it's very expensive on Ethereum. The dollar cost is very high. Yeah. Is the mined data primarily numeric, or also involving establishing connections between various entities involved in the chain? It's not only numeric. It's also you get this kind of network data. Who's transferring money to whom? How much are they transferring? Which exchange did that money come from? Which smart contracts are they using? Which games are they playing? All of that is publicly available from the blockchains. Do we collect data about oracles as well? In fact, we do. One of the research projects that we have that we're just sort of starting up, because we ended up using the Chainlink verifiable random function, their coordinator recently. And I was very curious about their claims of entropy. So we're actually going to be doing analysis of like the amount of entropy available in Chainlink random numbers. also like the level of decentralization, right? How decentralized are the Chainlink oracles really? Like we're kind of interested in that, and we've started that research now. Thoughts on the potential of Polkadot? To be honest, like we're just getting into the bridging business. I think I'll be able to comment much more intelligently on that once we've built like a couple of bridges ourselves. It seems quite complex, but of course there are complex problems to solve with bridges. So, in general, when I see something that complicated, I like to build a version for myself so that I can really understand how much of that complexity is necessary and how much isn't. And so that's the phase that I'm in right now. Hubert, can Moonstream be easily adapted to read data on private blockchains? Blockchains based on Ethereum, you just like right off the bat, you can do it. So for example, it took us 1 day to add Polygon support into Moonstream, and that day was spent like bringing nodes online and syncing those nodes. So yeah, it's totally simple to read data on private blockchains if they're Ethereum based. Hyperledger, I don't really know much about it. I don't know if it's like EVM compatible or something. I suspect it's not. If it's not, then no. Yeah. Okay, and then there were some questions over here. Let's see, what were the questions here? So is Moonstream is Moonstream focused on technologies or in any specific domain like fintech or healthcare? No, we're not really focused on technologies in like those kind in like any specific vertical. Our core technology just makes it easy, literally, for any software to consume data from the blockchain and to act on it, right? That's really what we've built at the core, and that's useful for anyone that wants to act on the blockchain. Now, there aren't that many healthcare companies that want to like act on, at least on public blockchains, so we probably don't have a lot of interest over there. But there are fintech companies, for example, for whom this is really interesting. Yeah, we do talk with those companies a lot. Yeah. I heard that 2022 will be the year of meta universes. A lot of games on blockchain are going to be released this year. Yes, I think so. And it's really exciting. So I think like the big thing, I think the thing that sort of unlocked or that opened people's minds to this last year was there was a project called Loot Project, which was released on Ethereum. It was just a bunch of NFTs, and each NFT just contained like 6 lines of text. Each line described like one item that like a character in some sort of a fantasy game would equip on themselves. And it was 6 items bundled together, right? That was what the Loot Project NFTs looked like. And the cool thing that the creators of Loot did, it wasn't the NFT itself. Like a lot of people look at that and they say, hey, this is stupid, right? It's just like 6 lines of text. But what they did was they built a community of people that would build worlds around the NFTs that they released. So they actually showed, most NFT projects, even though they're using blockchains, they're not really decentralized because there's usually like one company or one like team that has like very tight creative control on what happens with that project. And with the Loot Project, they just completely inverted that model. They actually built, they provided material around which people could build decentralized narratives, right? If I want, I can release a blockchain game and I can incorporate items from Loot Project NFTs into my game. And you can do that, you can write like a story generator, or you can make movies, and you can incorporate like Loot Project items into your movies in some way. I don't know what that would look like, but it's possible. And both of us could do that in parallel. And both of our projects are completely valid, and both of our projects could be very profitable and generate a lot of revenue. And we wouldn't be stepping on each other's toes. And the Loot Project guys are okay with it. I guess they get some kind of, they definitely get some kind of benefit from it. But like that's what the project was created for. And this really like shows the possibility. Loot, L-O-O-T. I can type it here. It shows that it just changes the model for how content is created, and I think it's like so exciting, right? Like now you don't have to build a complete game. Like you can build the seed of a game. Like you can describe like a fantastic setting or like something like this, and then you can engage like an entire community of people in actually building like a common experience around that game, which is like I haven't experienced that kind of collaboration at that scale. I haven't even seen collaboration at that scale anywhere else except Wikipedia. Like, Wikipedia is a place where people collaborate at that scale. But, what reward do people get for like contributing to Wikipedia? There's not much monetary reward. There is a social reward, but there's not a monetary reward. I think it's really interesting that the blockchain opens up like collaboration with the possibility of, for example, being able to support yourself. Like, you could work as a game maker, as a storyteller on a blockchain as part of a community like this, and actually support yourself doing so. I think that's really exciting. Yeah. So that was about about meta universes. We're building ML models to estimate price of NFTs based on transaction/sale data. It would be nice to have feedback. Yeah, sure. Just reach out to me, join our Discord and reach out to me, and I'm happy to talk, Jerry, anytime. Tina, thanks. Thank you. Jewel, do you believe that only very few? Okay, that I think we answered that one in the other one in the Q&A. Can you comment on blockchain versus Hashgraph? Not really. It's been a long time since I looked at Hashgraph, and I haven't thought about it recently, so I cannot comment intelligently on that. Polkadot answered in the other thread. Will your slides be made available? Yes. Yeah, I'm happy to share this presentation. How do you spell the name of a boot project? Okay. How can you educate yourself on where certain smart contracts are being deployed to know what data you want to crawl? This is actually a really good question. So it depends on like what you mean when you say certain smart contracts. Like do you want to do classes of smart contracts? For example, let's say that you wanted to know where NFTs were being deployed. Every NFT has like there's an NFT interface that the NFT has to implement. So you could just look for all contracts that are being called using methods from the NFT API or that emit events from the NFT API, and that would give you like a pretty decent way of identifying where NFTs were being deployed. If you want to identify like if one contract is deployed to multiple blockchains, you can actually look for commonalities in the deployed bytecode. So every smart contract has like some bytecode that executes its functions. So you can look for similar bytecode that's deployed across multiple chains. So there's a few different ways to answer that question. It depends, and I'm happy to talk more. I guess we're running out of time. It's 1 p.m. now. But if you want to talk about this further, I've thought about this a lot. How do you discover things that are happening on a blockchain if you don't already know what you should be looking at? If you want to talk about it, please definitely hit me up on Discord, and I'm happy to continue the conversation there. Yeah. Gul asks, what do you think about synthetic data generation from metaverse? I think I don't see I don't see a strong use case right now. I don't know why I would do that, but maybe I just can't imagine. So again, this is something I would be happy to talk about sort of offline. Yeah. Thank you, everyone. Thanks for having me here. I know I talked a lot, maybe very fast as well. I apologize for that, but I enjoyed talking to all of you, and thank you for your questions and the engagement. Yeah.
Thank you, Neeraj. It is a great presentation, and it will be in YouTube. A lot of people are asking. So you can rewatch that again, and we will share those slides.
Yeah.
And appreciate for everyone's time. It's fantastic.
Actually, if you give me 10 seconds, let me make the slides public and share the link right here. Let me.
Oh, that'd be great. That's much better. Yeah, more easier.
All right, I'm pasting them in. I'm just slides. There are the slides, guys. So please feel free, and I'll also send them to you in a separate email, Murat. Yeah.
Thank you.
All right. All right. Have a nice day, everyone, and good night to some of you, and good night to you, Murat. Yeah. Bye.
Thank you. Bye.